In this video, I'm going to be going through probability for grade 11 level. Specifically, I'm going to show you the different probability rules for grade 11, as well as going through Venn diagram questions, which are very important. So first, some probability theory. So here are some important rules for grade 11. Before we get into that, just quickly on the signs that you see in probability or you might come across. So this funny upside down N looking thing means and. The one that's flipped around means or. It's like a U shape. If you have A dash, that means everything that is not A. And obviously if you had A, that means everything that is A. The probability of A or P of A means the probability of A. NA means the number of elements in A, so that's different to a probability. A probability is a number over the total number of elements within the whole set, whereas NA is the number itself of those items within a set. But although these signs are important, the funny N looking thing or the U looking thing, you can also write these things in words. So for example, instead of writing the probability of A and B, you can write the probability of literally A and B. Or for example, the probability of not A. But it's perfectly acceptable to use the notation in this box at the top. Okay, so here are some of the rules for grade 11 that are important for you to know. First are inclusive events. So this is when the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. So what this means is two events are inclusive if this rule holds true. Mutually exclusive events, this is when the probability of A or B is equal to the probability of A plus the probability of B. You can see that formula looks quite similar to the inclusive formula, except it's missing that part at the end, the probability of A and B. So that just means the probability of A and B is 0, meaning these two events don't overlap at all. In that first one for inclusive events, this would be a Venn diagram that looks like that, where that's A and that's B, and we have some kind of an overlap. And we're saying probability of A or B equals the probability of B plus the probability of A minus that intersection of where they're both valid, A and B. So we take that away so we can actually find what's the probability of A or B. Whereas in the second example, for mutually exclusive events, the Venn diagrams don't overlap at all, meaning there's no intersection. That's why probability of A and B is equal to 0, because there's no place where these two events overlap. Thirdly is exhaustive events. So this is the probability of A or B is equal to 1. So that means all the data is covered within A and B. And it could be overlapping as well. That just means there's no data on the outside of those two. Because remember, you can get stuff that falls outside of two given events. Lastly is independent events. So this is given by the formula, the probability of A and B is equal to the probability of A times the probability of B. So this is a formula that you probably haven't seen before. The others you probably came across last year in grade 11, in grade 10. But for independent events, this is a grade 11 level formula that you need to use. So if you're asked about independence in a question, you just use this formula to show things are either independent or not independent. So if it holds true that the probability of A and B is equal to the probability of A times the probability of B, that means the events are independent. If they do not equal, then you say the events are not independent. Let's move on to some examples. For any two events A and B, it is given that probability of A is 0.48 and the probability of B is 0.26. Determine the probability of A and B if A and B are independent events. So if they are independent, then the formula that holds true is the probability of A and B is equal to the probability of A times the probability of B. So let's see if that works. So if the events are independent, those two times together, probability of A times the probability of B, will equal the probability of A and B. So therefore, the probability of A and B is equal to our two probabilities times together. So 0.48 times 0.26, which is equal to 0.1248. So this is one of those questions where they're saying if it was independent, what would it be? Whereas other types of questions might ask you to prove or to assess if it's independent or not, in which case you would assess the left-hand side of that formula and the right-hand side of that formula. Okay, question B, the probability of A or B if A and B are mutually exclusive events. So from the formulas that I did at the start, for mutually exclusive, the formula is probability of A or B equals the probability of A plus the probability of B. So again, we're saying that determine the probability of A or B if it's given that they are mutually exclusive. So we just use this formula. So probability of A or B is then equal to 0.48 plus 0.26, which equals to 0.74. So both of those questions we're just using the formulas and applying the formulas to the question. Just as a note, probability can be written in two forms. You can write probability as a fraction, so such as a half, so the chances are 50-50, or you can write it as a decimal. Both forms are acceptable, such as 0.5. So these two things mean the same. Probability will always be a number that is 1 or less. It can never be negative. So it's always essentially sitting between 0 and 1. And it can be 1, it can be 0. So there can be no chance of something happening, as well as there can be complete certainty that something will happen. Okay. Let's do another question. In the Venn diagram, the number of outcomes in each event are shown. So we have a set, which you can see is signified by S on the outside of the block, and everything in there represents the elements that are within this particular set. And we have an event A, an event B, and an event C. So in A, we can see there's 11 plus 3, and in B, there's just 3 plus 16. The overlap is 3. On the outside of both of those events is 10, and on the inside or the event of C, there's nothing. So there's nothing, no one is doing event C or choosing event C. So the first question is, what is N of S? So N stands for the number. So there's a number of pieces in set S or in event S. So that would be S includes this whole block. So we have to include everything within that block. So N of S is equal to all of these values added up. 10 plus 11 plus 3 plus 16, which equals to 40. So that's how many pieces of information are within this particular set. Next question, name a pair of events that are mutually exclusive. So this means two events that do not overlap. So we can see event A and B do overlap. we can see they share a 3 in common. There's 3 people or 3 times that these two things overlap. So it's not A or B. But then what's the other event here? The other event here is C. So neither B or A overlap with C, right? So there's two options for this question. You only have to put one. So A and C are mutually exclusive, or B and C, because both of those two events, A and C and B and C, don't overlap. So therefore they are mutually exclusive. If this question asks you to prove it, then you would have to show using the formula for mutually exclusive or for inclusive, and show that it's not true, to show that. But this question is just asking you to name. Okay, next question. Determine the probability of C. So as we can see, the probability of C is 0, because it will be 0 over 40, which equals 0. Just as a reminder, probability works by putting the number of elements within a particular event over the total number of elements within the set. So that's why we put 0 over 40. Okay. The probability of A and B. So this Venn diagram is nice. This is how why Venn diagrams are useful, because we can do these combinations. So the probability of A and B will be where the two overlap. So it's over there, right? So there's 3 pieces within there over our total, which is 40. So that's our answer, 3 over 40. Next, the probability of only B. Okay, so the probability of only B means there cannot be an overlap with A. So that is all the space over there that does not then touch with A. So just B. So that would be 16 over our total 40. And remember, if you use common fractions, you need to simplify. So that's equal to 2 over 5 in its simplified form. Next is the probability of A or C. So the probability of A or C, so the probability of A is 11 plus 3, and the probability of C, or the number of events in C, is 0. To get the probability, you put it all over the total, which is 40. So we're left with 14 over 40, which simplifies to 7 over 20. And that's the probability of A or C. And with that A, we included the 11 and the 3, because A also includes that 3, not just that 11. Okay. Are A and B independent? So the check for this is the probability of A and B equals the probability of A times the probability of B. So let's check this out. So on the left hand side, probability of A and B is 3 over 40, and the probability on the right hand side of probability of A, which is 14 over 40, and the probability of B is 3 plus 16, so 19 over 40, times those two together, you'll get 0,16625, which is not equal to 3 over 40. So that means, therefore, the left-hand side is not equal to the right-hand side, which means that the probability of A and B is not equal to the probability of A times the probability of B, which then means, therefore, probability of, or rather, events A and B are not independent. Let's move on to more trickier Venn diagram questions which have a lot more information and it's less abstract. So Venn diagrams are visual representations of the number of elements in a given set consisting of various categories. When working with these questions, try work from the middle, in other words, the intersection outwards. Usually at a grade 11 level, you would get 3 different categories. So there would be various overlaps, and the one overlap will be all 3 categories overlapping. So try work from that inside outwards, meaning first work from the 3 intersections, then work from the 2 intersections. There should be 3 2 intersections, and then move on to the ones that are alone, and then finally move on to the ones that are outside of the 3 categories. Sometimes you might need to make one of the overlaps equal to a variable, and then use that variable in some way to solve equations at some point to find the actual values. So don't forget, if the whole set has not been covered within the given categories, the remainder exists outside those categories. So usually in these questions you would be told that there's a total of however many people or things within that category, and if all of those aren't covered within the categories, then the remainder sits on the outside of those circles. Okay, so here's an example. A group of 33 learners was surveyed at a school. The following information was obtained from the survey. So 2 learners play tennis, hockey and netball. So the key there is and, right? And is telling us that they play all 3 of those sports. 5 learners play hockey and netball. 7 learners play hockey and tennis. 6 learners play tennis and netball. A total of 18 learners play hockey. So the complete hockey circle will add to 18. A total of 12 learners play tennis. 4 learners play netball only. So that will be just by itself, right? And they've added in some of that information for us on the diagram. Okay. So let's work out this first question. A Venn diagram representing the survey results is given alongside the information. Use this information to determine the values of A, B, C, D, and E. So that corresponds to all the missing values within the Venn diagram. Okay, so let's start with A. So we look at A. So A is that piece over there, which is the intersection between hockey and tennis. So let's look for hockey and tennis in our list. So there it is. We say 7 learners play hockey and tennis. We've already accounted for 2 of them in that middle intersection, right? So it's 7 minus 2. So A would be 7 minus 2, which is equal to 5. Okay, so that's that piece of information done. Next, let's do B. So B is the intersection between netball and tennis. So let's look for netball and tennis. Here it is there. It says 6 learners play netball and tennis. We've accounted for 2 of them, which is that intersection. So 6 minus 2 would be 4. So B is 4. So let's fill these in. 5 and 4. What I recommend is doing these in pencil so that you can erase them if you feel something's wrong. Okay. C is the total number of hockey. So then we go to the total number of hockey over here, and 18 learners play hockey, but we have to remove the ones we already have, right? Because there's already 5 that play hockey and tennis, there's 2 that play all 3, and there's 3 that play hockey and netball. So we need to remove those from that total of 18. So 18 minus 3 minus 2 minus 5. If you work that out, that will come to 8. So 8 people play only hockey. And then let's look at D. So D is only tennis. So then we go to that next bullet. a total of 12 learners play tennis. So 12 minus our intersections that we already have within that circle of tennis. You can see that circle of tennis is there. We've already got a 5, a 2, and a 4. So we need to subtract those. So then the total for D will be 1. And then I'll check for that. And you can do these for all of these to make sure all of these bullets that were given in the question actually hold true. Our check would be to look at that tennis circle only and add those values up. 5 plus 2 plus 4 plus 1. If you add them up, 5 plus 2 is 7, plus 4 is 11, plus 1 is 12. And let's check. Our question says a total of 12 learners play tennis, so therefore that's true. Okay, so this is how you check yourself. And then 4 learners play netball only. Okay, that's given. So then E is our last one, and E sits outside of our picture, or of those 3 sports. So E is the people who don't do hockey, netball, or tennis. So that would be the total, which we given in the question, 33 learners. So 33 minus everything else, minus 8, minus 3, minus 2, minus 5, minus 4, minus 4, minus 1. And if you add or do that sum, you should get to 6. Okay, so that's how you do one of those. Sometimes you might not be given an actual Venn diagram, and you would have to draw this Venn diagram based on the information. But like I said, you would then just work from the inside outwards based on the information given. So the very key piece here is that intersection, if you weren't given a Venn diagram, is the intersection of all the different events. And perhaps also the piece that sits outside of all the events. If you were given that, that's also a key piece, as well as the total of the entire set. And then you would work from the inside outwards. And like I said earlier, if you don't have enough information, you can use a variable, substitute the variable in, and based on the given information in the question, you can make equations to solve for it. The next question as part of this is how many of these learners do not play any of the sports on the survey. So that's asking for a number. That number corresponds to E, so that would be 6. 6 learners. Next question, write down the probability. So you need to read these questions carefully. The last question was asking how many of the learners, whereas this now in C is asking probability. So this will be a number that sits between 0 and 1. Write down the probability that a learner selected at random from the sample plays netball only. So this will be the piece that sits only there, netball only, which is 4. So that's 4 over our total of 33, and that's the simplified form, so that's your answer, 4 over 33. Okay, our last question for this. Determine the probability that a learner selected at random from the sample plays hockey or netball. So the key here is or. It's not asking and, so it's not asking for a small piece. Or means that it's quite broad. So let's look at the diagram. So hockey or netball means everyone who plays hockey, because it can be hockey just alone, or people who play netball, or a combination of hockey and netball. So that includes there as well as there. So all that we're excluding here is people who only play tennis and people who don't play anything at all. So that would be all those pieces added together, which is 8 plus 3 plus 2 plus 5. 8 plus 3 plus 2 plus 5 plus 4 plus 4 plus 1. I'm lying. Plus 4 plus 4. Plus 4 plus 4 over our total, which is 33. So that should simplify to 26 over 33, and that is its simplified form. So just to recap that question, it's asking for hockey or netball, so that includes everyone who plays hockey or netball. It doesn't matter if they only do one or the other, or if they do both, or if they do all three sports. What matters is we're including both full circles. We don't count numbers twice, we only count the numbers once in the picture, but we have to include both of the circles. Okay.